We turn now to the phenomenon of the elimination of antibiotics from the body. Let's suppose we have an antibiotic and we take 500 milligrams every 12 hours. And also it's known that in the average person, in 12 hours, the average person will eliminate 70% of the drugs that were in their body at the beginning of the 12-hour period. Let's see what happens. Let's say that at time t equals 0, somebody takes their first dose of the drug. Okay, they take 500 milligrams of the drug. So now they have 500 milligrams of the drug in their body at t equals 0. Now, at the end of the period, at the 12-hour period, how much are they going to have left? Well, if they're eliminating 70%, they're keeping 30. 30% of 500 is calculated to be 150. It's an easy calculation. And we also note that they've eliminated 70% of the 500 milligrams, or 350 milligrams. Now, at the beginning of the next 12-hour period, this individual has 150 milligrams already in their body, and they're going to take a 500 milligram dose, giving them 650 milligrams. At the end of the period, they'll have 30% of that 650 milligrams left, and that's going to be 195 milligrams, and incidentally they will have eliminated 70% of the 650, or 455 milligrams. At the beginning of the next period, they'll have that 195 remaining milligrams from the previous period, plus their 500 milligram dose, or 695 milligrams. They'll, at the end of the period, have 208 milligrams, and will have eliminated 487 milligrams. Now let's think about the process for a minute. What's the maximum amount that could be eliminated in a sustained, if this process continues? Obviously, we can't eliminate more than 500, or the amount of drug is going to decrease, because we're only taking 500 milligrams. If we eliminate more than 500, the amount of drug will decrease, and it's not going to do that. So somehow the amount eliminated is going to approach 500. We can symbolize the process by this difference equation. AN equals 0.3 times AN minus 1 plus 500. AN is the amount at the beginning of the nth period. AN minus 1 is the amount at the beginning of the previous period. Whatever we had at the beginning of the previous period, we're going to end up with 30% of it at the beginning of the next. And we're going to then add 500 milligrams by taking the dose. And that's the meaning and the interpretation of this equation. Now, we note that AN would cease to change if we did have a loss of 500 milligrams. So we ask, how much drug would we have to have in the body in order to lose 500 milligrams? What we lose is 70% of what we have, so if 0.7 of AN equals 500 milligrams, then we're going to reach a maintenance level of the drug. And here we'll say the maintenance level is a level at which AN is 500 milligrams divided by 0.7, solving this equation for AN. And we see that we have 714 milligrams approximately. This isn't always what we mean when we talk about maintenance level. A more traditional way of talking about maintenance level is to say that the maintenance level is the minimum amount we have. So maybe the maintenance level is 208 milligrams, and maybe we would want to use a different way of analyzing this. But we see that under these circumstances, if we have 714 milligrams after taking the 500 milligram dose, that we had 214 before taking the 500 milligram dose. The condition here was that the amount would cease to change, so we see that if the maintenance level is the minimum amount, it's going to be 214 milligrams.